In example number 2, we are once again going to use our 45, 45, 90 rule for special right triangles in order to solve it. And notice this one looks a little bit more complex because we have 2 square root of 6 in our numerator and 3 as a denominator. In this particular problem, when we have one like this, it is going to require a little bit of extra knowledge. You'll have to pull back from Algebra 1 how to simplify a radical. And if you forgot how to simplify a radical, simply go to the videos that are right before these, and you're going to see one that says Simplifying Radicals for Special Right Triangles. In that video, that short video, is going to give you a tutorial and show you exactly how to simplify a radical using prime factorization and perfect squares. And if you struggle with what you see in this video, you really need to go and watch that because you're going to run into this a lot when dealing with special right triangles. On the other hand, let's get started by first labeling our triangle here. Remember, this is a 90-degree angle right here. That's what this bar represents right here, that symbol. And this side is 45, and this side is 45. And our rule says that the 2 legs, which are the 2 sides of the triangle that touch the right angle symbol, are congruent. And we can just call them, for simplicity, x. And they're both the same. So if this is a 2, this one over here is a 2. You also have to remember that the hypotenuse, the longest side of the right triangle, is opposite the right angle. And over here, that value is going to be not only x, but times the square root of 2. Anytime we put a radical after an x, it means it's being multiplied to it. So x times square root of 2 is the size of the hypotenuse, where x is the size of each leg. Now, I got this written out because we're going to use this idea in order to solve for the missing sides of this right triangle on the left. And notice we're missing one of the legs, and we're missing the hypotenuse. We do know this is a 45, 45, 90 right triangle because we have a 90-degree angle, and they've given us 145. So if I were to add that together and subtract it from 180, we would be left with 45, which means this missing angle is also 45. Therefore, we can apply our rule. Now, what I'm going to do is I went ahead, notice I'm going to label my hypotenuse. And starting out, I have right here, this side is my A side, my A leg, I like to call it. And it tells me it's already 2 square root of 6 divided by 3. Therefore, B also is going to be the same value. B is going to be 2 square root of 6 divided by 3. And that's based on this 45, 45, 90 rule. So this one is real easy. We didn't have to calculate anything. We just simply took what this leg was and put it as the answer for the missing leg, B's value, because we know that these 2 sides are congruent. This side of the right triangle is congruent to this side of the right triangle, regardless of how the image looks, because these images are often not going to be proportional. Now, the more complex part of this problem is solving for C. Now, I told you earlier in the video that C is this x times square root of 2. So I'm going to write that. It is x times the square root of 2. However, this is going to be a little complicated. That contains a square root in it. So for some of y'all, that may confuse you, especially if you forgot how to simplify radicals in Algebra 1. So I'm going to go ahead and show you what to do. I'm going to substitute for x, so I'm going to put a parenthesis. And I'm going to write this value inside of there. So we have 2 square root of 6 over 3. And then we have to bring down this square root of 2 that's being multiplied to it. Now, if I were to write this out, and I'm going to do a little bit more writing here just to give you some space so you can see everything very clearly. I'm going to rewrite this right here. And remember that I'm multiplying this square root of 2 to the numerator of 2 square root of 6. So we have 2, I'm going to start putting some multiplication signs in here, times the square root of 6. And that was over 3. But then we also have to multiply that fraction by square root of 2. So times the square root of 2. So I'm going to go in and do some math here. Anytime you have radicals, if you forgot, when you're multiplying radicals, you basically just multiply what we call the radicand, which is the number inside of the radical. So this has a 2 in it, this has a 6, so this is like saying 2 times 6. So this actually becomes the square root of 12. In other words, to get this 12, I simply took the square root of 6 and multiplied it to the square root of 2. I'm going to move this up just a little bit because I'm going to keep working down. Now, this 2 is still being multiplied to those two radicals. So I'm going to take that 2 and just rewrite it down here in front of the radical. And I'm going to put that dot there because it just helps remind me that this is being multiplied together. Now my denominator is 3. We still got to bring that denominator down as well. So this is all over 3. Now, while some people might stop here, you actually cannot stop here because the square root of 12 can be simplified. So I'm going to go ahead and just circle this, and I'm going to simplify it separate over here on the right. So I'm going to write simplify radical. And you always got to check to make sure your radical can't be simplified, because if it can be simplified, you have to do that before proceeding any further. So if I want to simplify the square root of 12, I'm going to do that by what I call prime factorization. Now, when I say prime factorization, is my goal is going to be to pull any prime numbers that exist out of this radical. And common prime numbers, I'm going to write a note right here for you. Prime numbers. These are the numbers that I just memorized because I use them so often when I'm simplifying radicals. And they'll simplify the majority of all radicals that you'll interact with, if you can remember these. And so they're 2, 3, 5, 7, 11, and 13. And what I have found in the majority of times, probably 90% of the time that I've dealt with a radical, one of these numbers is going to be able to simplify it. And so I'm going to break this down, basically making it look like a number tree. And I'm going to write its factors. In other words, the two numbers that will multiply to give me this. Now, we already knew that, right, 2 was multiplied to 6, and that gave us 12. So 2 is definitely going to go into this. And we could use 2. So I'm going to go ahead and just break it back down. But I'm going to continue to break it down all the way until it cannot be broken down any further. And if you're asking yourself, well, how do I know, Mr. H, that it can't be broken down any further? Well, if you either hit a prime number on this right side of your tree, or if you hit a perfect square on the right side of the tree. And for those who forgot what a perfect square is just a number that can be created by multiplying two numbers to themselves. Like, for instance, 4 is a perfect square because 2 times 2 is 4. 25 is a perfect square because 5 times 5 is 25, and so on. So I'm going to go ahead and just use 2 for simplicity on this one. I'll use different numbers on the next one if we have another one that comes up with 12. And for instance, I can multiply 2 and 6. And 2 is a prime number, so I put it on the left, and then I put the other value on the right. And then I'm going to break it down further. I can break down 6 by multiplying the values of 2 and 3. Now, for those of you who have trouble memorizing your multiplication, and I'm one of those individuals myself, I always admit to it, I love using this prime number factorization, because if you didn't know that 2 could go into 12, you would just start out with 2 because it's your first prime number on the list that I gave you, and see what it worked by putting it in your calculator and doing 12 divided by 2. And then you would just take 6 and divide it by 2 to see if it'll work again. And if it doesn't work again, then you move to the next prime number. And if that one didn't work, you move to the next one. And once you run out of prime numbers to check, then you know that it's going to be what we call a surd, which means something that cannot be broken down any further. It cannot be simplified any further as a radical. Now, notice I did get a prime number on the bottom right. I got a 3. 3 is one of my prime numbers. I know that I can stop, because we can always stop whenever we either hit a prime number or a perfect square. So I'm going to go ahead and I'm going to circle what we have and rewrite it. So I currently have square root of 2 times another square root of 2 times the square root of 3. And where this may look like it hasn't really helped you out yet, the fact is it has, because we have the factors that it takes to get to 12. In other words, let me show you what I mean. If I do 2 times 2 times 3, it gives me 12. Now, why this is important? Because there's a rule with radicals that says anytime you multiply a radical to itself, it becomes the radicand. In other words, it becomes just the number that's inside of the radical. So square root of 2 times square root of 2 just becomes 2. And what we have left is what we call a surd, and it's the square root of 3. Now, I know that this can't be simplified any further, and so what I'm going to do now is I'm going to use 2 square root of 3 in place of the square root of 12. So I'm going to rewrite this. Instead of 2 times square root of 12 over 3, I'm now going to write it as 2 times 2 times square root of 3 all over 3. So I basically rewrote this fraction that you see that we got with a 2 and a 2 and a square root of 3. And that's because we simplified this radical here. Now, we still have some multiplication we can do at this point. I can simply multiply this integer of 2 times this integer of 2. And 2 times 2 gives me 4. And then I'm just going to bring down the square root of 3. I'm not going to put the dot anymore because there's no way we can simplify it any further. I'm just going to bring down the rest of the values. And then 3 is our denominator. And this is our answer. So C is equal to 4 square root of 3 divided by 3. And this is as simplified as it can get.